To this day, Sir Isaac Newton remains one of the most outstanding scientists of the world. The laws of motion, which he published in 1687, laid the foundations for continuing achievements in the physical sciences. The science of rocketry is an application of Newton's statement, by increasing the velocity of an object, we may at pleasure increase.
So he created the word rocket. So like he created like a propulsion word. I mean, I'm just a little bit skeptical of all that. Like, I mean, there's obvious. Thinking of talking to you here. Yeah, I mean, there's obvious requirements for an explanation, like of matter or invisible particles to, exceed the common idea. I didn't know he invented the word rocketry or talked about rocketry.
The distance to which it might be projected, until eventually it might even go around the whole Earth before it falls.
Yeah, so again, sort of like a propulsion effect. And yeah, without any knowledge, it would be, without talking to people of this age or without talking to neo people, it'd be difficult to figure out the moon and uh, but this, regardless, like I digress though. I mean, would it be that difficult to figure out the moon is revolving around, like find the group of outcasts in the civilization, 10,000 years ago, and talk your little science stuff while the religious people are being religious.
The man who wrote this prediction of artificial Earth satellites.
I mean, I'm not in favor of like voting for people that are, Christians, but everybody are Trinitarians, but everybody in politics these days are Trinitarians, so you can't get by with anything. They're all Trinitarians. They're all Christians. So you don't really have any chance to, I don't know, like to do anything about the system. So it's a good notion to have to understand that there was a sort of a religious debauchery of physics. Because yes, I wouldn't care if Newtonian mechanics were, say, the last Greek mechanics, last philosophically sound mechanics, and then with kinetic energy, you already have quantum entanglement. You already have quantum mechanics. I'd say because you do diversify the matter, and you isolate the matter. I mean, it's just never going to be helpful, or to even call it something other than the matter that is, like to not call it force matter or force bits, um, like force bits, matter bits. Oh no, we have to have force bits, matter bits here on Earth, and then outside in space we're going to have dark matter. That just is unacceptable. So I see that. In the long run, for sure, it just is really painful to watch. So, but I mean, the idea that there's a photon that can just, I don't know, maybe the idea that the photon is transferring through energy and it's still, uh, well, it's collecting energy and it's still using energy it already had. So it still seems like it has a duality. Um, it seems like it has just a smaller duality than the atoms. I know atoms are more neo too, but it seems like photons are pretty modern too in relation to Newton, which is like a little bit scary, regardless. So yeah, to have a more naturalist philosophy of science would be my standard.
Was born on Christmas Day, 1642, in the modest country house of Woolsthorpe Manor. During his early years at this school, young Newton was considered rather a dull pupil. Many of his biographers believe that this incident, a schoolboy fight,
I feel like I've watched this in school or something.
made a lasting impression on the shy and withdrawn Newton. For suddenly this boy turned on his adversary and won the fight. Newton's victory brought him a new self-confidence. Within a few months after the incident, his work showed a remarkable improvement. Good marks and hard work brought Newton a scholarship at Trinity College, Cambridge. During his student years, he spent most of his time in his room reading. He had become interested in the sciences. Drawing from the heritage of great scientists and mathematicians, he read works by Euclid, the ancient Greek mathematician, by Johann Kepler, the German astronomer, by René Descartes, the French philosopher and mathematician, and by Christian Huygens, the Dutch physicist. Newton might have remained an undistinguished scholar if it had not been for the guidance of a brilliant teacher. His name was Isaac Barrow. This professor of mathematics recognized that his young pupil was a natural mathematician and scientist. Professor Barrow set his pupil on the path of mathematical investigations, which he hoped would lead Newton to great achievements. Isaac Barrow had encouraged his pupil to think about the theory.
I mean, of course, they won't mention kinetic energy or Leibniz in this documentary, so it's mostly unfortunate. However, yeah, it is an interesting perspective. And then, needless to say, there's not really much opportunity for growth in our economic development, meaning scientific experiments. Like, how can we exceed billions and billions, if not trillions of dollars worth of scientific experimentation? It just seems so unlikely. It seems like they have hit their peak, or they've passed their peak. Maybe they passed their peak getting on the moon or Mars. Realistically, like, I don't see how they can keep going. Again, unless the whole oil thing is just a sort of like is going to be a much longer process. So I mean, it doesn't really matter either way if they do send stuff up. It's just the only thing that matters is that the space race will end. Um, and it's like it seems like it'll be long overdue. But I mean, if it is controlled, then what have they accomplished other than nothing? And just like extreme cases of quantum mechanics, like just really bad quantum mechanics. I mean, just to imply that kinetic energy was invented. I mean, quantum mechanics was invented when kinetic energy was, realistically, if you look at it that way. So, just the whole duality. Because yeah, I can interpret calculus to some extent when it's Newtonian, but as soon as yeah, there is squaring and halving and all that stuff. It wasn't really so much a return to philosophy as it was to just this new idea that was proposed, which was mathematics. It looks like, I mean, it looks quite obvious, like that mathematics was proposed when kinetic energy was, but they wouldn't say that. Just holding true that mathematics was always symbolic until kinetic energy.
That is, of mathematics.
And then when kinetic energy arrived, it just became this diluted way of thinking, which obviously precipitated, and I don't know if, you know, it makes it sort of seem like it's applicable, like for a school of thought today, like that it would help thought, but yeah, I don't think it would. I think it like could just be a waste of space or like an incubator for geniuses and stuff like that, just to have fun. But it's probably not a good reason to spend trillions of dollars on it.
Partly due to a strange series of events, Newton was indeed to carry on what his teacher had begun. By 1665, Newton had become a young teacher at Trinity College, Cambridge. One day he received horrible news. The bubonic plague had broken out in England once again. Many had already died of it in London, and
Sounds like propaganda to me, honestly, is another reason why they won't mention kinetic energy, just
as a
saying.
safety measure, Trinity College was to be closed. Teachers and students alike were to return to their homes. So, in the autumn of 1665, Isaac Newton returned to his home at Woollisthorpe. There he remained for 18 months, and this period in Newton's life was to become one of the most important in the history of science. In this quiet country house, he found the leisure to come to grips with several basic scientific problems. Here he was to work out the solutions to 4 major problems, solutions which were to usher in a new age.
Seems like he has his everything's paid for, kind of free housing sort of deal. I don't know, it just seems that way anyway.
Age of physics and mathematics.
Doesn't seem like an efficiency program he's in or something. He seems a little bit funded anyway.
The first problem had already been known in part to earlier mathematicians. It concerned...
I mean, I don't know how that whole thing works. Like, is it efficient, if they're funding scientists for breakthroughs anyway? Like, I mean, so that's like the oxymoronacy in it, like, anyhow. So you can't really get by. I mean, if the government is funding things for humanity's improvement, then, how is that going to, in the end, overall, help humanity? I mean, if you're not curing sentience, what are you doing? I mean, I guess that's one way to look at it.
Binomial expressions.
Not gonna swim out of atheism just yet for that.
Earlier mathematicians had known how to raise a binomial expression to the second or any power, as long as positive whole numbers were involved. But how should one go about computing a binomial raised to a fraction?
So binomials, you could say, are kind of well, binomials don't really relate to chemistry or like molecular structures. I don't think. Yeah, I remember stuff like that. I was never that great at this stuff. It was uninteresting to me. One of my earliest memories of my life is like getting an equation wrong. It was something like 2 plus 2 equals what? And I wrote 5, and the answer, like I got my answer wrong, and I'd like walked up to the teacher and like, How is this not the right answer? How is this not the right answer? So math always pissed me off. Maybe after that. I mean, my brother's really good at math. He's probably the only one in like a family of 6 or 7. I can't fucking remember, but that's good at math. So yeah, I can't even remember how many people are in my family. 6. Only one of them's good at math. This calculus stuff. I don't know about binomials. I'm pretty sure that's algebra, obviously. I don't really know what qualifies as calculus anyway. I guess sort of calculations. So it makes sense.
Fractional power. For example, 5 halves. Assuming n to be any exponent, a whole number or a fraction. Newton to be any exponent, a whole... Assuming n to be any exponent...
Yeah, F, so he is talking about force. That's interesting.
A whole number or a fraction. Newton grasped the basic relationship between exponents and coefficients. Thus, he created the Binomial Theorem, a fundamental principle of algebra. Using Newton's theorem or formula, A sum of any two variables can be raised to any power, whether fractional or whole, whether positive or negative. These are Newton's original notes for the binomial theorem. It was the first of his four great achievements at Woolsthorpe. In November 6...
It's pretty amazing how their handwriting was like typewriters. I mean, it was like so efficiently like aligned and all that. It's pretty interesting.
1665, Newton was completing work on the second problem, which had its origins in geometry. Ancient geometricians knew that the tangent to a circle lay at right angles to the radius. But in general, it was not known how to find the tangents to other kinds of curves, those without a radius. In working out the method for finding the tangent to any curve, Newton laid the foundations of a new branch of mathematics. The differential calculus. Even more important, Newton found that by inverting the procedure used to find the tangent to a curve, he could calculate the area of a curvilinear figure. This discovery came to form the basis of a...
Yeah, so I mean, it does just seem that he did create calculus. I don't know what the debate would be. It seems like, yeah, physics is a little bought out by religion or Catholicism, and yeah, just it makes sense. I mean, if he was measuring curvatures and everybody's fooled thinking that Einstein's doing curvatures when I don't think well, I mean, again, like, how can he be? So, I mean, yeah, these simulations and all that, like I said, they don't really seem necessary for the cure. They just seem necessary for maybe more preventative measures. But even, again, we know that oil was the cause of the boomer and the baby boomer. And, yeah, so, it's not going to happen again. It's something that's not going to happen again. We're also not going to, be able to pull magnetism out of the Earth's core or something, and derive the necessary permittivity to be able to survive a famine. Well, we'll have a famine, but it won't. I don't know. It'll be like the Great Famine of 2200 or something, 2050 or 2150. Something like that. That'll cure us. But anyway, it is interesting that the way they elaborate this. I mean, because if he was studying that stuff or algebra in that sense and calculus, then yeah, it's a little bit absurd that they keep this going to just prevail the competition, the competitive nature of science and geniuses, and again, really just putting them in incubators and letting them play around with letters and numbers. I mean, it just doesn't seem. It's interesting, but not that impressive.
related branch of mathematics, the integral calculus. The calculus which alone made possible...
So binomials are 2 degrees of exponency, and 3 degrees means they're, what do you say, trinomials or trifectas?
The amazing advance came to form the basis of a related branch of mathematics, the integral calculus. The calculus which...
Yeah, integrals are pretty lethal to me. They don't seem, it just seems like, well, it is getting into physics and all that. I mean, it is getting into quantum mechanics and all that. And again, he was into Descartes, and Descartes was, into his little Bible or whatever. So I mean, I'm just pointing it out. I'm just saying maybe there is a new standard for atheism. I mean, I doubt they'll talk about his anti-Trinitarian ways. I mean, if they do, that's great. I'd like to hear more about that anyway. But yeah, it is. I am skeptical seeing that he was up against Leibniz, who was actual Trinitarian, and he was an anti-Trinitarian. So yeah, but just doing all these things, and then blaming Leibniz for being a Trinitarian when he's doing the exact same math or integrals and all that binomials, which they're definitely using. Like everybody's using these things. So what difference does it make? To me, it doesn't really make a difference. But yeah, this whole war on science is pretty interesting because yeah, they're all pretending that they're Satanists or something. Like there's this demon quality. I mean, that's insane. I mean, they're calling it like Laplace's demon, which is determinism. So, determinism. They're basically saying if you believe, like science basically says, like if you believe in deterministic quantum mechanical value, and you can interpret that the world is deterministic, then you can qualify all the negative outcomes, um, or maybe it's all the outcomes in the future must be negative. So if you qualify everything in the past, then you must understand that everything in the future will be negative, and that's like Laplace's demon. And it's not even a mathematical theorem; it's like it's like an idea. The guy was like a poet or something. It's pretty weak.
Which alone made possible the amazing advance of mathematics and physics, was formulated by Newton in one single stroke of genius. In January 1666, he turned to a third problem. The problem was one of physics, the nature of light. In a series of experiments, Newton used a circular beam of sunlight and a glass prism. Newton allowed the light beam to pass through the prism onto some white parchment. But the circular beam of light now appeared oval in shape. Also, it was no longer white, but a spectrum of color. This could mean only one thing. Some of the light rays passing through the prism had been bent more than others. The prism acted as a sorting device. It dispersed light rays into their various color components. Thus,
Yeah, this whole oh man, I mean, I mean, so I don't see how it's such a big accusation for Newton to say. Newton saying, well, yeah, there's bent space here on Earth. Talking about curvatures, binomials, and whatever the other thing was, that other subset, mathematics, and now basically Einstein's that new guy, but he's doing it with space. I mean, it doesn't make sense. Like I say, I do think their theories are nice on paper, but I would never take this stuff literally. Like I would never talk about it literally, like the geniuses do, and I would sure as hell never understand it in that way. Again, they're good reads, but yeah, I don't believe in what they preach.
the experiment proved that what we see as white light is really a mixture of colors. Astronomy, too, fascinated the youthful genius.
It's pretty interesting how that he just got that idea from a rainbow. He didn't prove the rainbow. He just said, "Oh, there's light contains all light." Doesn't sound that smart.
He was making a new kind of telescopic instrument, one which contained a highly polished reflecting surface. But he did not complete his telescope at Woolsthorpe. A famous account tells us that in 1666, the fall of an apple started Newton on the way to his fourth and perhaps his greatest achievement. Newton knew that the apple was attracted to the Earth by gravity, a force already known to earlier scientists. But the question which now occurred to him was,
I like how they said this all started because he beat up his bully. That's pretty legit.
how far did the force of gravity extend? Newton recalled that Galileo
By the end of his life, he doesn't. By the end of his life, he's so successful, he doesn't give a shit about the guy in second place at all. It's pretty badass. But That's how Einstein was, I'd say. But these people today are nobody's. Uh, you can't really, you can't get footage of Galileo, all that. But yeah, Newton and Einstein, big deal. Everybody else, you know, like I said, if they don't learn about them in high school, chances are they'll never hear a letter of their name in their lives. And these guys, it's just Elon Musk now. He's not a scientist; he's a businessman. So. And a huge natalist on top of that, like Einstein was. Yeah, I don't really like Einstein for that. Just,
Leo, another scientist, was reported to have dropped weights from the Tower of Pisa during his experiments with falling objects. Well then, thought Newton, if the force of gravity extends to the tops of trees and tall buildings, might not that same force extend into outer space? To the moon, to the planets.
So that same force, the force of the apple, is supposed to extend to the moon and to the planets. That is, wow.
Continued to puzzle Newton. Even at night, he would suddenly wake up and remember it.
What the fuck is that thing on its head?
Could it be that this force, this gravity, actually kept the moon in orbit around the Earth?
I can't believe, I can't believe Galileo hadn't figured that out yet. Like Galileo didn't figure. Well, they figured out the rotation. They knew that the moon was orbiting, right? So now he's just saying, now he's saying, okay, that's gravity.
It must be true. Newton grappled with this revolutionary theory, sometimes working all through the night until dawn. And at last, through mathematical proof, he was able to show in these original notes that gravity not only keeps the moon in orbit around the Earth, but it also keeps the planets in their...
I guess he never. I guess he was never mentally ill either because he never stayed up after staying up all night. He never stayed up through the dawn. He would stay up until dawn. So yeah, that's when the vampires go back to sleep, I guess. But anyway, yeah, all the angular stuff. I mean, he's testing all these angles here. Like that takes a lot of dedication for sure.
timeless orbits around the sun. Although Newton did not publish his new theory until many years later, we now know that he had already formulated at that time the famous law of gravity, or gravitation.
Let me read.
And so during
Law of gravitation. Any two bodies in the universe attract each other with a force which varies directly as the product of their masses, and inversely as the square of the distance between them. Yeah, that's fine. There's like some overlapping going on there with the Earth and Sun, but the Earth still has the Moon. But it seems like integral equations, they really do, or integers, they really do express this spinning like quality. All right, so Galileo figured all that out. Okay, Galileo figured out the orbits, and then they just don't have words for orbitals and stuff. And I don't know, it's all cringy because science gets called the devil by religion, and everybody in science knows that religion is complete crap. But a lot of scientists are full of crap. So.
And so, during his 18 months at Woolsthorpe, Newton had perfected the binomial theorem, the differential and integral calculus, his theory of light and spectrum analysis, and the law of gravity.
And math, okay, that whole discovering the rainbow thing, that was kind of, but whatever. Discovered it, and then yeah, discovering gravity. Yeah, I mean, well, these are also labels. This will be known as gravity. This will be known as the light spectrum. So that's interesting. And then you get your scalar for light, your 7 different colors of the rainbow, and yeah, it's off. So it's again, just this help. This all right, but I would say it's by all means the truth. If this is really how Newton um, progressed his sciences, with kind of like a phony way. I mean, it's not as bad as it's not as bad as a clay experiment. Seeing a rainbow through a crystal prism with no colors of the rainbow, just saying the colors of the rainbow are there, or seeing gravity, or just seeing the moon and just seeing the moon going around, calling that the force of gravity. So that's okay. I mean, it's definitely above kinetic energy, saying, well, there must be something in the air that is all wrapped around this thing. But it is really unfortunate that nobody talks about that. Those, like in that order, sort of plausibly. Um, it is, yeah, I'd say it's really unfortunate.
That's No, so what I want to say is the following: is the memory effect. I mean, or the net gauge transformation. I mean, if you see, this is what I want to emphasize: is that there's a physical observable, and then there's the pure gauge part. So, yeah. Okay. So.
So what was I saying? Kinematics. Yeah, I forgot who.
That's. I mean, there's a gauge transformation which takes you to sigma equals, sorry, CZZ.
Definitely paused out. Kinematic equations. It's gotta be I can't remember who invented them. Kinematic inventions. Invention. I remember it was like no well, it doesn't really matter that much to me, obviously, but I know Lewin just Lewin just put something out there for it, so it was I disregarded it, but it started with it.
Takes you to sigma equals, sorry, CZZ equals 0. Exactly. Wait, so maybe let's see. Let's make sure we're on the same page.
She talks so fast.
So what I say is the following. Say I'm sitting here now today, and I have.
It's kind of funny how they talk about, they're calling it a null, like, the telescope hasn't reached far enough. I mean, it's just, yeah. I mean, after I heard the firecracker theory, I was just like, no, this is unacceptable. But this is what these people go to school for. It's just to, learn all the same stuff that Newton was doing. So
Some like set of masses, and then there's some profile, and then it jumps. So in a sense,
So what are you drawing?
I'm drawing along. Sorry, I'm drawing. Okay, maybe this isn't the best. I'm just time. I was just gonna like return a time roll in a null direction just for the sake of matching the diagram, but I can just do it this way. So
and this sciencey stuff doesn't take sentience serious. It's just factual. Um, this is always for innovation. There's not much innovation to be had. Again, constructing or having an efficient work, management, job site or something, it's not really doing anything anymore. It's just not. There's no more efficiency out there to be had because efficiency turns into just work. And yeah, it's just proprietary and ran by political psychos. So, like Bezos. I mean, this whole Taylorist thing instead of, I guess, a modern money currency deal.
At any given angle, so say at fixed z, then I can imagine that there's nothing, and then there's some jump, and I have this arbitrary function in the sphere.
But yeah, I do think Gary's a Taylorist now that I've sort of opened my eyes to Taylorism and this efficiency trap. And I mean, is it like super fast communism, or like a quicker way to get to communism? I mean, that's what the idea is, right? Like Jeffersonianism. But yeah, it's just horrible. So yeah, you can't vote for it, like he says.
So just drawing that this function has changed. And so if I have a set of masses, this would look like they move by a little bit from where they were initially just set. So this is like two different angles in this one. Right. So for the super translation case, you can think of the memory effect as you have a set of masses on a sphere far away that are test masses, and then you can look at, say, like geodesification equations and see that this net result of the radiation coming is just going to be some net displacement of those masses. And so like that's the memory effect. Now, the connection between super translations versus that is that.
And you've got a Laplacian squared or something you've got to integrate to get to the super translation from the delta MB.
For the delta MB. So what happens is for NZ and turn it into a relation between NZ and TUZ. Basically, this term becomes that guy when you integrate over the whole region instead of just the contour. And so basically, you have an expression where angular momentum flux gives you what you can interpret either as a time delay if you have these fixed bond BMS coordinates, or in a sense would be like a Sagnick effect and the ring would rotate if it was geodesic. So it's kind of cute that.
Again, she's done a really good job of explaining her, qualitative response to dark matter. Dark matter just being this fluid substance, and you plug this in, or you plug in a charge effect, continue the chaos, and you get, and then you get a spin effect from the charge memory, from the fluid memory in the dark matter, and this is optics. That's just what it is. Just these memory points, and they distribute all of these plugins. She does a really good job of explaining it, but it's just bullshit.
Basically, the intuition from what the memory effects are and how to like pick out what the like zero energy observable is for the other soft factors, and the fact that we have this triangle and we expect to also see something for when we have this new soft factor that Freddie and Andy worked out, and also super rotations is like a potentially extension to the super translations that are at null infinity. Then what's the memory effect? And like that type of logic leads you to this big memory effect, which is just either time delay or net rotation. So, any questions at this point?
Yeah, I got a question. What the fuck did you just say? No. Can I have your number? No, either. I wouldn't do that. She is fucking hot. Gotta stop thinking that way. No, I mean she does a good job.
There's a little bit of a teaser for the talk we get tonight or today's afternoon. It's actually kind of fun to think about. So the memory effect is basically telling you what happens. Say you have some charge that's accelerating. You see the radiation, and I wait a long time and I measure the radiation. So then what happens if you have a horizon? Then anything that falls in, you wouldn't see the radiation due to that acceleration after that point. So you can imagine that, like,
You can imagine that bent space doesn't exist. Wow, what a fortitude! I mean, what a persisting fortitude. I mean, yeah, there was never bent space, but they have to simulate it, right? I mean, that's sort of what Newton did with his calculation in the light spectrum, I would say. Um, yeah, and he was right about the elliptical, but again, I'd say one of his most famous experiments is the light spectrum, and he didn't derive, he sort of derived that from chaos, as they do, I'd say, with dark matter, the cosmologists, or these cosmoclists, these cosmological optic people,
I don't know, it's a fun way to like think about how would the memory effects
telescope lovers.
play out in this situation where basically there's a shadow to what you can see as an observer at null infinity. And so then you'd imagine if the final state were really hairless and had just some, like, say, electron-positron fall in, you would see maybe final state that was neutral, initial states that were the initial momenta of the electron-positron or whatever, maybe black hole that was initially there. And then that wouldn't necessarily gel with what you see as from the accelerations of the trajectories, because as it crosses the horizon, you wouldn't see radiation after that point. So that's just a way to play around with what would make the...
Yeah, it's kind of funny how they talk about these black holes or talk about these horizons, because the black hole is a horizon and everything. And, I guess all the particles from the charge all the particles from the charge that go into the horizon, that sort of notation is impossible to understand. Just the physics of it doesn't make any sense. Well, quite obviously, like sort of like the quantum gravity. This is the quantum gravity, right? Because you can sort of derive your galaxy from more of an anti-gravity theory, and with gravity, it's obvious that can play into the black hole. But then when it comes to quantum gravity, how are they going to figure out the black hole? And then, I mean, they have this horizon thing, and that's how the particles transfer, and then also how the radiation spews back or recycles.
horizon kind of natural in that perspective, but also that's where things go awry when you try to convert between a Cauchy slice and null infinity, unless you have something else coming into play. So it's a bit of a teaser, food for thought. Any other? I'm good. That's what I want to say.
More questions? Perhaps a naive question. Just does any of this, if you add this as maybe small cosmological cost, like
so okay, I don't I haven't worked out the details, but technically, naively, what I would do is I would go to a patch where effectively I can do the story and kind of like surround my region and then propagate freely out of that using the fact that there's now a cosmological constant to change what the propagators were and see where it would go. That's like,
Oh yes, Einstein's biggest blunder, blah blah. Yeah, that is way. I mean, we're all way attuned overly attuned to the cosmological constant. But yeah, they're all just plugins. That kinetic stuff.
how I would picture it. I would patch together the flat space like region where it's effectively fine. Say that the scattering occurred there, and then say that it's now these outgoing states or incoming states are free modes that propagate in your curve. Sorry,
So outgoing states and outgoing states and free modes. Yeah, because there can only be expansion, right? So that's it's a bit bizarre. I mean, obviously not in an orbital though, right? Because that's dealing with quantum like leaping. So yeah, just break orbitals with quantum leaping, And yeah, it just gets more and more confusing, more and more illegible. Just I don't know.